Okay, so far I have told you guys that sine, cosine, and tangent, and the other three that we haven't done anything with, only apply to right triangles, and that is true. That is not a lie. But there is a way that some brilliant person figured out to use these with triangles that are not right triangles also. Anybody have any right ideas how? Yes? Yeah, exactly. What we can do to make this into a right triangle is take and draw an altitude right there, and then now we have not one, but two right triangles right there, okay? And so what we're going to do is a little bit of a, I don't know, we're going to bounce through some algebra here. I'm going to call these sides, because I'm so creative, I'm going to call them A, B, and C. Isn't that original? And then I'm going to call that altitude right there H. Okay? H for Hannah, yes, exactly. Okay? And so we can take, like I said, and turn this into two right triangles by drawing a altitude right there, okay? And after we do that, I can come up with an equation for H using this triangle over here and then also using this triangle over here. And so if I want to do it with the one on the left, what I'm going to start with is I'm going to say that the sine of A equals what over what? H over B, opposite over hypotenuse. Okay? Which means that H equals what? Sine A times B. Yeah. Sine A times B. Okay? Then I'm going to do the same thing with the triangle here on the right. And this time I'm going to use angle B. And what would be true about angle B? The sine of angle B, I mean, how would you figure that out? H over A. Is this making sense? Opposite over hypotenuse. Opposite of angle B is H, and the hypotenuse is A. All right, if I solve that for H, what would I get? Sine of B times A, right? So far, nothing crazy? Okay? Well, since this thing right here equals H, and this thing right here equals H, what can you say about those two things? They're equal to each other. So I can also write that the sine of A times B equals the sine of B times A. And that's basically the law of sines. But they're going to do a fun thing instead to make it easier to work with. I'm going to, just because I feel like it, divide both sides by AB. Just wanted to do it. Okay? What happens with the stuff on the left? What cancels? Just the B's, right? Because this is a capital A, which stands for the angle. This is a small a, which stands for the side. So the capital A and the small a don't cancel. What happens over here? The A's cancel. And so what I'm left with is a really easy to remember proportion, which, like I said, is the law of sines, which now we can use with any triangle at all. And the law of sines says sine of A over A equals sine of B over B. And that's pretty easy to remember, right? And then there's one more thing that we can add on to it. What side did we leave out here of this whole thing? C. But do you recognize that we could do the exact same thing if we had decided to draw our altitude that way instead? And so that's going to work out to be the same. And so to finish the law of sines, the sine of C also equals, or sine that also equals the sine of C over C. Okay? So that's a really, really simple one. The sine of A over A equals the sine of B over B, which equals the sine of C over C. And it's very handy, like I said, because you can use it for any kind of triangle you want, not just for right triangles. Now, have you noticed a relationship between the way the angles have been labeled in the triangles that you've been working with and the way the sides have been labeled? They're always opposite, yeah, and that has to be true. Angle B and side B need to be across from each other. Angle A and side A need to be across from each other. And angle C and side C have to be across from each other, okay, for this thing here to work. So this is the sine of the angle over the side that's opposite it, the sine of the angle divided by the side opposite it, and the sine of the angle divided by the side opposite it. Those will all come out to be the same thing, all right? So now that opens up an entirely new world to us. Yay! And the people rejoice. Because now, like I said, we can do this with any old triangle that we want. It does kind of look like a right angle, doesn't it? Do you think it is? Do you think it is? Could be. Let's find out. Ooh, pretty close. Pretty close. But it's not. But it's okay. It doesn't have to be. Okay, so I need, and I also need a couple angles. So let's say A is 59 degrees, and B is 38. Okay? And let's find all the missing pieces to this triangle. Alrighty then? Okay. Yes? But, I'm out. It's not a right triangle. So we can't, I know what you're going with. You're going to say tangent of this is the opposite over the adjacent. And I did a bad job because that looks like a right angle because it almost is. But it doesn't have the little right angle symbol there, so we can't assume that it is. So as of right now, if it's not a right triangle, the only thing you know how to do is the law of sines that we just talked about. So the sine of 38, just start with that, what the heck, over what? B equals the sine of 59 over 350, okay? So the sine of this angle divided by the side that's opposite of it is going to equal the sine of this angle divided by the side that is opposite of that. And now you just have a simple proportion that you really did well with when we were working on similar triangles in the last chapter. Just multiply these two together and divide by that, and you should find out that B equals approximately 251 centimeters. So like I said, it would be a good idea for you to try that right now on your calculator. Make sure you know how to get that answer out of the proportion that we wrote. So go sine of 38 times 350 divided by sine of 59 degrees, and make sure you get the right thing. Erica?
Oh, I have a question that I
You got her? Okay. Take a minute to make sure that that's actually what you get when you do it. Okay, now let's figure out what C is. Okay? And in order to do that, we need to know the angle that's across from side C. We need to know what angle C is, which is not labeled, but we can figure it out. What is it? Okay, good. We remember from the very beginning that all these three angles are going to add up to 180. So if I go 59 plus 38, I get 97. And then 180 minus 97 equals 83. So this guy right here has to be 83 degrees. So give me a proportion that I can use to figure out what side C is. Sine of 38,
Why are we always using sine?
because I'll tell you in a second. Sine of 38 over, what's the length of the side opposite that? We just figured out that it was about 251 equals sine of 83 over c. Okay? So cross multiply and divide those. And I have no idea what you should get from that, but I'm sure someone will tell me in a second. Oral 5? Okay. All right, Alyssa asked a very good question, which is why are we only doing this with sine now all of a sudden? And that comes from the original triangle that we made, which is kind of a mess. Let me see if I can clean that up a little bit. But when I started out doing this, I did the sine of A equals h over b. Why did I do sine and not cosine or tangent? But couldn't I have used adjacent over hypotenuse or opposite over adjacent if I'm looking at this angle right here and this right triangle right here? No, why not? Right, because I don't know the length of the adjacent side because C is split somehow by this altitude, okay? So when I developed this to use it on non-right triangles, the only trig thing that I could use to do that was the sine ratio, okay? Because the other ones use adjacent and I don't know what this is. We're going to do something a little bit different tomorrow or maybe the next day, which is a lot of cosines, okay? So we're going to find a way to make that work, but this simple proportion only works with the sine function, all right? Okay, let's do one where we are trying to find the missing angle instead of the missing side.
Oh.
What just happened? Well, let's say that this is 150 and this is 250. And this guy right here is 69 degrees. And now I want you to come up with the measure of angle B. Okay? So starting out, at least the idea is the same. Give me a proportion that I can use that involves all of those things. Sine of 69 divided by 250, because that's the side opposite the 69 degree angle, equals sine of B, very good, over 150. Excellent, okay? So sine of this angle divided by the side opposite it is going to equal the sine of this angle divided by the side opposite that, right? Okay, so now we're going to cross multiply and divide again. What two numbers are we going to cross multiply to start with? The 150 and the sine of 69. So multiply those two together. And then what do we divide by? And then divide by 250. And tell me what you get from that. .56-ish? Okay, does that mean that angle B equals 0.56? No. What does that mean? Right, that means the sine of angle B equals that. What do I need to do to find the angle? I have to go inverse sine. Remember, anytime you're trying to find an angle, you have to use the inverse sine function. So once you get that answer, go second sine, and then tuck that, and you get what? About 34 degrees. Okay, good deal. So make sure that you remember that. If you're trying to find the side, like we were in the first example, then you can just use the regular way. But if you're supposed to find the angle, then you have to take your answer and go second sine of that. Does that make sense? Okay. All right. Oh, I was trying to figure out why it's so quiet in here now. I know. There's adding to it.
How did you find the number?